If you look in the box near the middle of page 2, you will see the definition of inverse function. Okay, now keep in mind this is out of your textbook. Okay, and a word of warning, when we read through this box, it's not going to make any sense. Okay, but once we read through it underneath the box, we will spend time kind of deciphering what this box is saying. Okay, so definition of inverse function. It says, suppose that f is a one-to-one function, then to each x in the domain of f, there is exactly one y in the range because f is a function, and to each y in the range of f, there is exactly one x in the domain because f is one-to-one. The correspondence from the range of f back to the domain of f is called the inverse function of f. The symbol f inverse is used to denote the inverse of f. All right, see what I mean? You got nothing out of that. Okay, that's okay. Okay, let's talk about all the things that this box is trying but failing to tell us. All right, underneath the box, okay, the first statement there, okay, this is how I want you to think of an inverse function. Okay, let me highlight it. Okay, it says, think of the inverse of a function as the reverse of that function. The inverse function undoes the operations that were done on the function. Okay, so think of it as the reverse of a function. Okay, so I'm going to give you an example. I'm going to make this up. Okay, let's say my function is, let's keep it simple, 2x minus 5. Okay, so basically think about if you have an x value, what does this rule do to the x value? Okay, and you've got to follow the order of operations. Okay, the first thing that would happen to the input or the x value is it would get multiplied by 2, and then after that you would take that result and you would subtract 5. Okay, that's what this function does. Okay, so the first thing it does is it takes the input and it multiplies by 2. And then after that it gets that result and it subtracts 5. Okay, so what the inverse function would do, okay, and the inverse function is going to be its own function. The way we denote it is with this notation f inverse. It looks like it's f to the negative 1 power, but that's not what it is. That's just the notation for f inverse. Okay, it's going to be its own function, its own formula. It's basically going to undo or reverse everything that the original function does. Okay, so the original function first multiplies by 2 and then takes that result and subtracts 5. Okay, we have to undo this. Okay, so we basically start at the end and go backwards to reverse this. Okay, so the last thing that the original function does is subtract 5. Okay, so we're going to start there. We're going to reverse that. So the first thing that the inverse function is going to do, okay, is it is going to, what's the opposite of subtraction, is going to be addition. It's going to add 5. Okay, so you need an x. Okay, so you would take the input and you would add 5 to it. Okay, and then after that, the original function, after it subtracted 5, it would multiply by 2. So you've got to reverse that now. We've already reversed the subtracting 5 by adding 5. So the opposite of multiplying by 2 would be dividing by 2. Okay, so we take the x value, we add 5, and now we're going to divide by 2. Okay, this is going to be the inverse function right here, x plus 5 divided by 2. Okay, it undoes everything the original function does. Okay, the original function first multiplies by 2 and then subtracts 5. Okay, the inverse function comes along and undoes all of that by taking the input and adding 5 and then dividing by 2. Okay, so that's how you want to think of an inverse function. Okay, so what I highlighted in yellow is important. Okay, it is the reverse of the original function. Okay, it undoes the operations that were done on the original function. Okay, Now don't worry, you're not going to do what I just did. Okay, if I give you a function, I'm not going to expect you to eyeball it and undo all the operations. There's a process for actually coming up with the formula. Okay, so don't worry about that. I'll show you that in a minute. Okay. All right, so before we start finding inverses, okay, you need to know these facts. There are 6 very important facts at the bottom of page 2, facts about a function and its inverse, okay? As we go through the remaining examples in this section, you will see these illustrated, all 6 of these, okay? Very important, okay? All right, number 1. Okay, remember we were talking about one-to-one functions and I said they were very important for inverses? Well, here's why. A function must be one-to-one in order to have an inverse function. Okay, so basically not every function has an inverse. Okay, in order for a function to even have an inverse, the function has to be one-to-one. Okay, so only one-to-one functions can have an inverse. Okay, so let me jot that down. Okay, only one-to-one functions can have an inverse. Okay, number 2, the symbol F inverse is used to denote the inverse of F. Okay, the symbol F inverse does not mean 1 over F. Okay, why am I bringing that up? Well, you've probably seen this before. Okay, if you have a variable, not a function name, if you have a variable raised to a negative power, then it is true that this is like x to the negative 1, it is the same as 1 over x, okay? But if you have a function name it looks like it's raised to the negative 1 power, that's not what's going on, okay? That is just indicating F inverse, okay? When you see that, it is not 1 over F, okay? Number 3, and this one's going to be mucho important, this one. Okay, if xy is a point on the graph of the original function, then yx is a point on the graph of the inverse function. Okay, have to know this one. If xy is a point on the graph of the original function, then if you just switch x and y, the point yx is going to be a point on the graph of the inverse function. Okay, so what you'll see in a few minutes to find an inverse function, it comes down to switching x and y. Okay. Number 4, the graph of an inverse function is the reflection of the original function about the line y equals x. Okay, and you will see this illustrated in the next few examples. If you take your original function and you graph it, and then you graph the inverse function on the same grid, if you the original function and the inverse function, they are going to be symmetric about the line y equals x. Okay, they are going to be mirror images of each other about this line y equals x. Okay, number 5, another important thing. Okay, the domain and range of a function and its inverse are interchanged. Okay, so let me say a little bit more about this one. Okay, what's going to happen here? The domain of f is going to be the same as the range of f inverse. And the range of f is going to be the same thing as the domain of f inverse. Okay, it all comes down to the reason behind this. It all comes down to the switching of the x and the y. Okay, so the domain of f is going to become the range of f inverse, and the range of f is going to be the same as the domain of f inverse. Okay, and again, you will see this illustrated. Okay, the last characteristic in number 6, this is referring to composition of functions. Okay, remember when we talked about composition of functions, the order matters, and most of the time if you do the composition in both directions, you won't get the same thing, meaning f of g is not necessarily, most of the time it won't be the same thing as g composed with f. However, if you are dealing with an inverse function, okay, so if you have f and its inverse, f inverse, if you compose them in either direction, you're going to get the same quantity, okay? So f inverse composed with f. So if I'm looking at this statement, this is f inverse of f of x. Okay, so f inverse is the outside function and f is the inside function. So if you do the composition in that direction, and then if you also do it in the other direction, so you do f of f inverse of x. Okay, so now f is on the outside and f inverse is on the inside. If you do the composition in both directions, you're going to get the same thing, namely x. It will simplify to be x. If that happens, that is one way to check whether two functions are inverses of each other. Okay, so keep that in mind. If you have a function and its inverse, if you compose them in either direction, you will get the same thing, and they will compose to be x. Okay, something else I don't have on this list: a function, the inverse of a function is unique. Okay, so if I give you a function f and I ask you to find its inverse function and you find it, that's its inverse. There's no other function in the world that can be its inverse. Okay, so inverses are unique.